It says find the value of k such that this x to the third minus kx squared plus 2 has a remainder of 8. All right, so it means that when I divide this by this, I get a remainder of 8. Or that when I do, I don't know why it's making funny noises, the f of 1, I get a remainder of 8. Right? Well, that is equal to 1 to the third minus k1 squared plus 2. So 1 minus k plus 2, that's a 3. So if I subtract 3, I get 5 equals my negative k. So k equals a negative 5.
Okay.
All right, does that make sense?
That makes sense.
All right. Show that this x to the 51st minus 21x plus 20 is divisible by x minus 1. Now, do you want to divide that out even using synthetic division?
X to the 51st.
Yeah, you don't want to do that, do you?
No.
No, but I can say that it means that my f of 1 has to equal 0, right? So if I check my f1, I get 1 minus 21 plus 20. Does that equal 0?
Yeah.
Yes. Then it is divisible.
Which gives you x to the 50 minus 20.
Well, no, it gives you a really, really long thing that you don't want to do,
Man.
honestly, because like every other term will actually show back up. Yeah. Which is the reason when you do division, you have to do the x to the 50th plus x to, 0, or 0x to the 49th, and all of that is because they show back up. All right, so this is an awful horrible problem, but it says find the value of w. So here are w's, such that this has a remainder of negative 9.
Why?
Because they want us to. So in other words, my f of negative 3 would have to be a negative 9, right? Which is w negative 3 to the third minus w times negative 3 minus x, oops, sorry, negative 3 squared. Yes? So my negative 9 has to equal negative 27w plus 3w minus a 9, so minus 9. Oh, well, when I add my 9 and I add my 9, I get 0 equals negative 24w, so w equals 0. That's a silly problem.